Sorry all, we're just getting the live streaming set up.
Awesome. All right, welcome back everyone. It's my pleasure to introduce Kerrie Dougherty. Kerrie Dougherty is an independent space historian, curator and writer, and a lecturer in the Space Humanities Department of the International Space University. She is a member of the International Academy of Astronautics, serving on its History of Astronautics Committee, and also serves on the International Astronautical Federation Space Education and Outreach Committee and its Space Societies and Museums Committee. She has a special interest in the history of Australian space activities, and this is the focus of her PhD research. So please join me in welcoming Kerrie Dougherty, who will be talking to us about what has space ever done for us.
Good afternoon, everyone. Apparently we don't have a laser pointer, so if I move the cursor around on the screen, that'll have to suffice, I'm afraid. I hope that'll work for everybody. Yes, the title of my talk today is What's Space Ever Done for Me? And you'll see I've included this little cartoon of the old codger who says, fully on space exploration, what's it ever done for me? And by the end of this talk, we're going to find out what space exploration has actually done for our little cartoon character. Now, most people, if you ask them, what's come out of space exploration, they'll tell you Tang, Teflon fry pans, Velcro, and space pens and space food sticks. But the truth of the matter is only one of those is actually a product of space research. Do you know which one? Sorry? The pen? Now, that's an interesting thing. A lot of people think NASA paid, there's an urban myth that NASA paid a huge amount of money to have the space pen developed. And in fact, a chap by the name of Paul C. Fisher took it upon himself for his own business interest to develop a pen that could write not only underwater but at any angle and was therefore suitable for writing in space. No, strange as it might seem, the only one of these that was actually developed directly by the space program was the space food sticks. Tang actually was a drink invented in the 50s, but it was used in the Mercury and Gemini missions. Teflon was actually developed back in the 30s. But again, NASA used it in spacesuits, in heat shields, various other insulation, can't think of the word I want. But they used it in a variety of ways throughout the space program. So again, all of these things got a big boost from being associated with it, but they were not space products. Of course, NASA did love Velcro quite a bit. As you can see, the Velcro was originally used on the Apollo spacesuits. I don't know if you can just see there, these are actually Velcro tabs that were designed to hold the tools while the astronauts were in the Apollo spacecraft and also working on the moon. But after that, NASA became very fond of Velcro, and you'll find it everywhere. If you can see this astronaut on the International Space Station, he's got Velcro tabs all along his pants so that he can stick his equipment and his notes to. All these little tools that come out of this toolbox, again, they're wrapped in Velcro, they've all got little Velcro tabs on them. The dinner plates have Velcro tabs so that your cutlery doesn't float away. There's nothing worse than having your cutlery and or your dinner floating off in the distance while you're trying to eat. And I rather love this. This is Catherine Nyberg, who was an astronaut on the International Space Station, and she was a quilter, and so she actually had made for her, or made herself, a lovely quilting mat out of Velcro. So as you can see, NASA loves Velcro, but they didn't invent it. However, NASA did give the world quite a lot of important innovations that have, in particular ways, gone quite a long way towards changing our society. And the most obvious example of that is the communication satellite. Originally developed by NASA. These days we can get live breaking news from any part of the world. We can have live interviews with people in any part of the world. If you've got your, with your smartphone, you can communicate to anybody, anywhere around the world. And of course, you don't have to wait for things to scream in America and come to Australia 3 months or 6 months later. You can now get them straight away. So communication satellites have been the most successful product of space technology, and certainly the most commercially successful product. Now, you may not know that, in fact, the idea of the communication satellite was first promoted by, Arthur C. Clarke, the science fiction writer. And back in 1945, he published an article where he showed that with only 3 satellites in a very particular orbit, which is known as geostationary orbit, at 36,000 kilometres above the Earth, if you've got 3 satellites in that orbit, you'll be able to provide radio coverage of the entire Earth, because at that particular height, the satellites are travelling at the same, in their orbit, the same speed that the Earth is turning below them. So they appear to actually be stationary above that particular spot on the Earth. And that means that we can now literally be in contact no matter where we are, whether we're in the Arctic or the Antarctic or the desert or wherever. And as communication satellite technology has developed, we're now able to communicate with aircraft, fixed terminals, ships, submarines, any kind of transportable device. You can go anywhere and you will have access to telephone communication. The very first communication satellite was this little baby. This is Telstar. This was launched in 1962. And here, I might add, is a lady who does understand and appreciate technology, even if our old codger didn't. But the very first satellite broadcast out of Australia was in 1966, and that was a program called Down Under Comes Up Live. And what's so interesting about that particularly is that it was only one way. Because of a particular, it's actually a launch failure that put a satellite into a very specific orbit that enabled Australia to send a signal via satellite to the UK, but it wasn't possible to get a return signal. So that very first program out of Australia was one way, but it was the start of Australia being linked to the world via satellite. And from the mid-60s on, there's an enormous growth in satellite technology. You may not be aware now, but the very first global link via satellite was in 1967, and it was a program that was called Our World. It was broadcast literally around the world with material provided by 6 or 7 different countries, including Australia. And for those of you who are Beatles fans, it was this program for which the Beatles wrote All You Need Is Love. And they actually performed it live. This is some very poor footage, but it's the only thing I could find to show you of the Beatles performing live on Our World. But having that satellite communication drew the world closer together. It's often said that the world became a global village. Suddenly we could see what was happening in countries that in some cases we'd never heard of before. It's very often said now that being able to see the reports from the Vietnam War directly on television via satellite was a very important turning point in support for that war, not only in the United States but in Australia and other countries as well. And since that time, the power of television and the power of live satellite communications has really changed the world in many ways. That immediate worldwide connectivity that we've got now with satellites, with the internet, with our smart devices, they're all linked up by fibre optics and satellites, and they're producing global change, a social change and globalisation at a very rapid rate. And now, in fact, we need to think whether or not is this a good thing or is this perhaps not a good thing. There are, quite a number of, obviously on the economic side, a lot of people think that globalisation is good for trade, but it could result, get my tongue around that, could result in a lot of changes to cultures, to politics, and of course globalisation of trade can actually lead to environmental changes in different countries. One of the interesting things that's often complained about in regard to the dominance of Western media through the communications media is that many countries, particularly many minority groups, are losing contact with their cultural heritage. And yet, at the same time, we have groups like many of the Aboriginal communities in Central Australia, Indigenous groups in other parts of the world that are actually using satellites now to retain and develop their culture. So they're using satellite communications into remote areas to broadcast in their language and to broadcast cultural programs to young people to help revive their cultures. So there's a two-way street. Satellites, of course, have actually been very, very important in distance education. You all know about the School of the Air, but these days they're no longer using radio, they're using satellite technology, so that you can actually have your classroom literally in a field as long as you have your satellite phone with you. And India is a very interesting example of, they were one of the first adopters of using satellite technology for mass public education. In a country where in the 1970s particularly, there were very few schools in regional areas, many poor communities simply didn't have access to higher education. And so they began a program putting satellite receivers and a local television receiver into each community so that educational programs could be directly broadcast. And that's something which is now huge in India. China does a lot of work in broadcasting education programs to remote areas, and it's quite widely used around the Pacific as well. So another thing that satellites, particularly communication satellites, enable us to do is telemedicine. And if you've never heard of it, essentially telemedicine is medicine via satellite. So that you have a health worker, perhaps in a remote region, who's outfitted with a kit, possibly like this one you see here, which can actually, it's a satellite phone combined with a small medical kit. And this can send information back to a doctor or a specialist in one of the big city areas, and they can provide further detail based on the readings from the different measurement devices that are sent to the doctor. So this is doing particularly important work in Africa now with telemedicine. They've got a lot of nurses who go out, community nurses who can go out to small regional areas, and just with one of these they can set up a small clinic and put the people in the village directly in contact with doctors back in the major cities. And of course it's widely used in Northern Australia, in Aboriginal communities, and again in a lot of other remote regions of the world. Of course, these days you all know that your phone comes with a GPS receiver. Your car might have a GPS as well. It's become so ubiquitous for us we almost don't think about the fact that GPS is another satellite technology. It actually began as a navigation technology for the for the United States military, and it works through a constellation of, I think it's now about 24 satellites that are orbiting around the Earth, so that 4 or 5 will constantly be in view of anyone at any particular time. And because of that, using the, I'm sorry, could I have some water, please? Using the signals from the satellites, the receiver on the ground can actually triangulate your exact position. And as we know, GPS is very useful for finding your way around, but it's very useful for a lot of other things as well. And these are things you may not actually think about. GPS has a lot of use in agriculture now, both for helping farmers at present plough their fields to get their maximum yield, so that they can actually plough right up to the limits of their fields. Thank you very much. And in the future, GPS will be able to be used to guide smart tractors or smart reapers, so that you won't even need a driver, just like the driverless car, which will also rely on GPS. These farm implements will be able to steer themselves around the field, being driven specifically by GPS. The world financial system now would actually fall apart if it were not for GPS, because all major, or in fact all international transactions of funds are all time-stamped. Every time you go to an ATM, take money out that's time-stamped using GPS, and so that way the global financial system can keep track of where money is at all times, where it's being transferred to, and if there's ever any questions about anything, it can all be tracked back via the digital timestamps of GPS. Surveyors, builders, infrastructure development, they all rely on GPS in different ways to help, excuse me for a moment, sorry, to help in getting the correct locations for I'm very sorry, I've just totally blanked out for a moment, for the different structures that they're working on, bridges, whatever, pipelines, they all use GPS these days. And in fact, in a lot of countries where they have earthquake problems, they can now use GPS to actually monitor the movement of faults. So along, for example, the San Andreas fault, which is quite famous, there are actually a set of monitors that use GPS to actually monitor how that fault is moving, how it's slipping, and they hope that that will be able to help them in predicting the possibility of another major earthquake. And this is something you may not be aware particularly. It's one of my favourite uses of GPS, in fact, is any movie you see now that uses CGI. This is a scene from Avatar 2. So, you know, we have our live actors, they work against their green screen, and the computer artists are going to put in all that other footage later. But how do they know the exact angles? How do they know how the live action people were standing or relating to each other in the physical space? Because the cameras are fitted with GPS, so that they know exactly what angle and exactly what location every camera was. And that way they can relate all the footage of the actors that was filmed in the computer and create seamless imagery. Thank you. Seamless imagery for the cinema. So, you know, just a few uses of GPS you may not have actually thought of. Now, how many of you go boating or bushwalking perhaps? Maybe you've got an EPIRB, or maybe you take the risk and go out without one. But if you do have a mishap of some sort, the International Satellite System, COSPAS-SARSAT, is there to help you. It's originally established in 1979 and consists of special instrument packages for receiving the COSPAS-SARSAT signals that are actually mounted on different satellites in geostationary orbit, and also some satellites in polar orbit. And these, they're mostly on meteorological or remote sensing satellites. And essentially the way that the system works is that, you know, if you get in trouble, you're a hiker, you get lost, you activate your emergency beacon, one or other of these satellites will pick it up, and they'll relay it then to a ground control station, and there are ground control stations in several major countries, and these are then sent on to the emergency services in the particular area where the beacon has been located. And these days you can actually get, you know, you can get beacons you can carry in your backpack or your pocket even, if you're a bushwalker, anything up to, of course, aircraft and any kind of ship. You can carry an EPIRB beacon, and if you're in trouble, they can find you. Of course, the one thing that is can be a bit of a problem is if you stick your EPIRB on top of the wardrobe when you come back from your hike and you accidentally activate it. And there's been a few cases of emergency services being scrambled to rescue somebody from home because they've accidentally activated their beacon. Weather satellites are another one of the earliest satellite technologies that have been used to benefit us here on Earth. This is a pretty bad image by modern standards, but that is the first television picture from space back in 1961 from the TIROS-1 weather satellite. And even though that's not a particularly good image, the first images that did come down from TIROS-1 over the Pacific actually enabled the identification of a typhoon that was going to sweep down on the Philippines. So they actually, for the first time, had advanced warning of a major weather event. Just as a way of contrast, this amazing image here was taken just about this time last year from Japan's Himawari 8 meteorological satellite, and it's not just showing the Earth, it's showing the Earth in its true colour. A lot of times when you see satellite images from space, weather images or other types, they've been treated through filters in various ways in order to enhance the colour or to enhance some feature that the processors want to bring out. But this is exactly what the Earth looks like from space if you were sitting up at geostationary orbit about 36,000 kilometres out. And as I was saying, weather satellites are particularly important for us here in Australia. They give us, Australia as we know is a very big country. It's impossible to have enough ground stations across the country to gather all the weather data for a comprehensive ongoing meteorological forecasting. So satellites make that task comparatively easy. Here we've got pictures both in daylight and in infrared. Weather satellites operate in both, and that way they can see at night as well, so they can watch the growth of weather patterns 24 hours a day. Again, weather satellites, you can find them at geostationary orbit, you can also find them at polar orbit. And I rather like, just wanted to show you this. This is what Australia looked like at 17:30, so 5:30 yesterday afternoon when I made this slide. And in this way you can see what they've put together is both an infrared image, so an image like this coming from one of the Japanese meteorological satellites, over a NASA optical or normal light image of the Earth. And that way we get a really good feel for exactly how the weather patterns are developing across the country and of course across the nearby seas and other land masses. Related to weather satellites, of course, are remote sensing satellites. Now you may not have heard that term particularly used, but essentially what a remote sensing satellite does, it detects the reflected solar radiation, that is the radiation from the sun, which is coming off the buildings, the ground, everything that the sunlight strikes on Earth reflects back up into the sky, but it reflects back up with certain changes that are dependent upon its material, how it absorbs the sunlight in different ways, so that you can actually detect these changes, and by processing them in different ways, you can discover a lot of features about the Earth that you simply can't see with the naked eye. So here, for example, these are 4 different images of Charleston, Carolina, or more precisely, they're the same image, but they've been processed in different ways, because with remote sensing satellites, you don't just look at the ground in visual light, you can actually look at it in other wavelengths into the infrared as well. And plants, for example, reflect a lot of sunlight in the infrared through heat energy. So you can actually determine things like how crops are growing, what their health is. You can even find archaeological remains under the ground, because if you have foundations in a field, they'll actually affect how the crops grow on top of those foundations. And with remote sensing, you can very often see the outline of the foundations, even though they're not visible to the naked eye. Another way that remote sensing, actually, I'll just mention this one too. You can see that a lot of images from remote sensing satellites, they're very colourful, and that's because we use different false colours to show up different aspects of the data that's been received by the satellite. So what we've got here, for example, is showing the phytoplankton concentrations in the area around Malaysia, in the seas around the Malaysian peninsula, in the South China Sea. So that, you have a scale here which tells you how they've decided to process it, and you can see that you've got much greater concentrations here, lesser concentrations in these areas. But what about when there's cloud? Well, you can actually even have remote sensing satellites fitted with radar, so that it doesn't matter if the cloud's there, the radar can see through it. And here, for example, is a radar image of the Irrawaddy Delta in Burma or Myanmar back in 2008, and it's actually showing how the flooding was occurring in that area. And you couldn't have seen that with it, from a plane because of the thick cloud cover at the time. And of course, because remote sensing gives us those wider views, we can study large areas in a single glance, as it were. So we can use that data for mineral exploration. So there's a lot of work done in the northwest of Australia, for example, with remote sensing data. You can use it for monitoring the environment in different ways. Now, these, for example, this is actually sand being blown off the northern Sahara into the Mediterranean. Here we're looking at a part of far north Queensland, and you could actually see areas where there's been enough rainfall to allow for healthy tropical growth, and areas where some of the plant communities are actually drought stressed, so that in fact you've got die-off in these areas here. And for those of you, and I'm sure you do here, remember Black Saturday in 2009? These images like this were actually used to surveil where the bushfires were and how they were potentially spreading. So you can see with a visual image, you can see a lot of smoke. What the smoke hides is the active fire fronts, and so with infrared, and this of course has been highlighted particularly so that you can see it clearly, but infrared then enables you to spot where the active fire fronts are. So this is a tool that's being used more and more here in Australia, particularly for bushfire fighting. Because satellites give us that overview, we get a very broad view looking back at the Earth. They're very good, as I mentioned, for studying these regional changes. And one of the things that satellites first pointed out to us was that we might have to think about the possibility of climate change. You might remember the discussion about the ozone hole back in the 1980s and 90s, when they discovered that CFCs were causing damage to the ozone layer around the Earth. This was actually first discovered by satellite and was tracked continuously. Here you can see 1980, and this is a series of tracks all the way through to 2004, and you can see how the hole has mostly grown, occasionally contracted, but it enables us to, especially over time now, to build up those long-term pictures of what's happening. So remote sensing is incredibly important in studying the environment in general, but particularly what is or what appears to be happening with climate change. So, for example, here's an analysis of methane in the atmosphere. Here we're looking at carbon dioxide concentrations. This is showing you how the El Nino and La Nina effects can be tracked across the Pacific. So by using the tools of satellites with those broad area views, we can keep an eye on what's happening with our environment, we can look for pollution, and so we can become good stewards of the Earth through the data that satellites provide to us. And in fact, you may not be aware that the environmental movement got a big kickstart from space in the 1960s. Before then, we'd never seen the Earth from space. We really didn't have, how can I put it, a visceral idea of what the Earth was hanging in the cosmos. But when the first pictures from the Apollo astronauts came back, they really showed us that this ball of rock that we live on really is a spaceship Earth. This is the famous Earthrise picture from Apollo 8, Apollo 17's whole Earth, which is said to be the most reproduced picture in history. I don't know if that's actually true, but it's certainly something that's been claimed on many occasions. But seeing the Earth as that fragile spaceship in the blackness of space gave a big impetus to the environmental movement by the end of the 60s and into the 70s. And in fact, this is a poster from the very first Earth Day held in the United States in 1970, and the image they're using there is this image from Apollo 11 that had been sent back the year before. So space was actually, it's not only important to us for monitoring the environment from space, but it has actually helped to promote the consciousness of the need for good stewardship here on the Earth. Now, although a lot of people don't necessarily like to discuss it, I'd just like to briefly mention military space activities. Because, again, something that you don't often think about. During the Cold War, spy satellites were actually incredibly important in arms verification. So, you know, you may have heard of things like the SALT treaties, Strategic Arms Limitations treaties. How could America know that Russia was actually living up to the treaties? How could the Soviet Union know that America was? By using their spy satellites. They could actually see what was happening on the ground. This is a KH-9 hexagon spy satellite. This was a type used by the Americans in 1971 to 86. It's now a declassified satellite, and this one's actually on display in the Air and Space Museum in Washington. If you actually happen to get there, you can see this formerly top secret technology. And these are the kinds of images that were actually sent back by these sorts of satellites, so that, for example, in this case, they could see the types of Soviet naval cruisers or battleships that were under construction in the shipyard, or in China they could see a new type of bomber that other intelligence had suggested the Chinese had built. So by being able to see from both sides what the other side was doing, this actually was one of the things that prevented the Cold War from actually turning hot. And we often forget that without this kind of surveillance technology, the world might be a very different place today, because our Cold War history may have taken a very different turn. And that kind of technology that was originally used only in spy satellites has now, of course, become available in commercial imaging satellites. So this is a view of Sydney from the Digital Globe, one of the Digital Globe satellites, and you can see the amount of detail in that. So that these days, images like that can be used for town planning, infrastructure development, or infrastructure planning. Again, it can be used in disaster planning and also in disaster recovery. But a lot of people ask that question, well, what about privacy? You can actually get satellite images that are even more detailed than this. And where does there come a point where it's not just our city councils or our government needing to check things for infrastructure purposes? When does it come to the point that they actually have enough resolution that they might be considered to be spying on us? So this is a question that needs to be considered as this kind of technology develops further. I'd also like to talk about a few more specific kinds of spin-offs that have come from space technology. Those are the big picture ones that come through space applications. But people always like to know about the ones that perhaps affect them a little more closely. So I'll just talk about a few now that you might find of interest. These examples I have drawn from NASA. I would also point out that the European Space Agency and excuse me, other space agencies do try to spin off their technology developments into commercial products that can be of value and use for the local or their own communities. Now, something very interesting that came out of space in the very earliest days of space exploration was the concept of wellness. Now, you may not sort of think of that, but up until the 1950s and 60s, essentially medicine had looked at how to fix you when you're sick. But when NASA needed to find out what the limits of the astronauts' normal responses were, so that they could check on whether or not something strange was happening in space, they actually discovered that there wasn't a lot of data on how people are physically in their normal state when they're well. And so this began an interest in not only looking at ways to cure people when they're sick, but to consider what is well, what are the conditions of people when they're well, and how do we keep them well. And so that became the impetus for the concept of wellness, which is now an important part of overall medical strategy. And of course, keeping an astronaut fit and well in space has always required, as we've discovered, the need for exercise because, excuse me, because when you're in that microgravity environment, your muscles don't have to work hard, your heart doesn't have to work hard, and you gradually lose your cardiovascular conditioning, you lose your muscular conditioning. And so NASA, the USSR, have looked at, how do we keep people well in space and stop this deconditioning occurring. So they developed things like this treadmill that you can see Andy Thomas, the Australian astronaut, on in the Mir space station. And that kind of equipment has now found its way into use in gyms and things. This, for example, is, excuse me, it's actually a horizontal trampoline. It was first used on the space shuttle as an exercise device, and now you can find them in various gyms around the place. So, and I believe used in rehab centres as well. So they've become, one of the many medical technologies that help keep astronauts healthy in orbit, and now they're finding their way into use on Earth. This is quite interesting. This is the vascular pump. It was developed by NASA in conjunction with some heart surgeons in the United States, and it's designed to keep your heart working while you wait for a heart transplant. So this is something that came out of development for the potential of problems on a long-term space mission. Supposing an astronaut develops a serious heart problem, you can't conduct a heart transplant in space. So how are you going to keep them, keep their heart functional until they get back to Earth? A lot of research has come out of NASA's interest in robotics and also in comfort materials, if I can use, or comfortable materials. And a lot of that research has actually now been channeled into the development of prosthetics. So you've got various prosthetic limbs which have cups that are made of materials that have been developed. For example, like you've all heard of memory foam, I'm sure. So this is something that was originally developed by NASA, and of course, apart from being used in pillows and things, it's actually very good as a medical device, so that, for example, if you have the stump of a leg being fitted into that, it's cushioned and protected by the foam. And various of these prosthetic limbs, for example, especially the hand and the arm here, are now being fitted with feedback devices and actuators that have come out of NASA's robotic technologies to create improved mobile prosthetics. And in fact, there's even materials research that has now created skin, or artificial skin for these prosthetics that gives them the look and feel of human skin. This has come out of materials research that NASA has been doing. Surprisingly, this is the most popular product that has apparently come out of NASA, and that is the invisible braces for orthodontics. Apparently, certainly in the US, it's the most sold orthodontic product of all time. But quite important for the psychological well-being, if not necessarily an improvement on the physical aspects for young people who need braces. Various other medical devices. There's the infrared ear thermometer, used quite a lot with babies particularly. And in fact, when was it? Round about back in the early 1970s for the Skylab program. NASA was looking at whether or not microalgae could be developed into a product that would be both nutritious for astronauts to eat, could provide oxygen as part of their respiration process, and ultimately could be used to digest human waste. And they looked at certain types of microalgae, and they found that they couldn't actually get that 3-in-1 problem solved, but what they did discover was certain microalgae that are actually very rich sources of omega-3 and that can be included into baby formula to make them much more nourishing. And so now I think something like 95% of the baby formula in the world contain this development from NASA to enrich the nutrient value of the baby food itself. Kidney dialysis, some of the improved filters used in kidney dialysis today come out of techniques that NASA was developing to separate soiled or contaminated water so that fresh water or potable water could be reclaimed from it. And of course that's a technology which is now being used on the space station, where they can produce drinkable water from the crew's urine, but it also has that application in kidney dialysis. And this is actually something I find really fascinating. You've all heard of MRIs. Probably several of you have had an MRI scan at some time. Well, NASA didn't invent the MRI, but what it did invent were some of the imaging technologies that came out of JPL, that the Jet Propulsion Laboratory, that then made imaging of the MRI data more accessible. It actually improved how the MRI data could be turned into images that doctors could then obviously use to diagnose particular problems. I'm sure now almost everybody here has got a wireless earphone of some sort, or you've got one on one of your video games, or you've used one at some time. That's a technology that comes directly from the wireless headsets that were developed for the Apollo program. So here's Armstrong actually wearing his Snoopy hat, as they called it, with the two wireless mics. And the company that developed those for NASA is still developing wireless headsets today. They've been one of the pioneers in that field right the way through. Apollo also helped to give us the cordless household equipment. So, for example, Black & Decker actually had developed some early cordless tools, but they then worked with NASA on developing the cordless lunar drill. And that research gave the impetus then to the later development of things like the dustbuster or the cordless drill, and that whole range of cordless tools that I'm sure you're using at home. They all come out of NASA's need for reliable battery-powered tools that could be used especially in the vacuum of space. Heat-resistant materials. After the loss of the Apollo 1 crew in 1967, NASA put a lot of research into developing heat-resistant materials for spacesuits and flight suits. Now, of course, those materials can be used by firefighters, they're used by racing car drivers, excuse me, they're also used in the military. In a similar way, the cooling garments that NASA originally developed to go under an astronaut's spacesuit are now used for what they call cool suits. So they can be used in areas like, think of the word I want in a second. They can, if you're going into, where you're having to, get my tongue around this, when you have to work in an area where you may be in a high temperature environment, or perhaps when you're wearing a radiation suit and you need cooling underneath it, these cool suits have come out of that original technology. And in fact, there's an interesting variant that's been created specifically for people who have a very rare disease which prevents their body from properly cooling itself. And so NASA-derived cooling suits can actually help these people keep their bodies at good temperatures. In fact, NASA filtering technologies have been used to develop gas masks for soldiers, and also lightweight gas masks for firefighters, who now don't have to carry a huge oxygen tank on their back because of the development that's enabled the oxygen tank to be miniaturised and carried on the waist, and then with a lightweight mask. So these all, assist the firefighting community. There's quite a number of firefighting tools that have been developed through NASA research, as well as the Jaws of Life that we'll see just in a moment. Scratch-resistant sunglasses actually come to us care of the coatings that were originally applied to the visors. of Apollo astronauts. And as I mentioned, the jaws of life, they come out of technology that was originally used in the clamps that hold down the space shuttle at launch. Variable level smoke detectors, these were originally invented for the use on the Skylab space station. The space blanket, I'm sure most of you have either heard of them or seen them or probably used them at some time. Very thin sheet of mylar plastic with a metallised coating. And this is a technology that NASA first developed back at the end of the 50s and used in two inflatable satellites. They were like giant balloons floating around the Earth that were made of aluminised mylar. They were called Echo 1 and Echo 2 back in the early 60s. Now we get to our space food sticks. You remember I said at the beginning they were one of the only technologies that people think NASA invented that they actually did invent. And why did they invent them? So that the Apollo astronauts would have something to eat while they were out on the lunar surface. So here you can actually see Gene Cernan from Apollo 17, and you can just see the food stick sitting up above the rim of his helmet. So when he was out on the lunar surface, you could actually lean over and bite the top of the space food stick and pull it up a bit so you'd take another bite and so on, so that you'd have a little something to eat on the way. They were developed by a commercial company in the US, and then they decided that if they were good enough for the astronauts, they were good enough for the general public, and so they've been marketed since then as a snack food for campers and for kids. And in fact, NASA, of course, has had to do a lot of research in food technology, and that's given us some pretty amazing improvements in the way that we process food, in the way that food safety is regulated, and also in how we make our camping food and our TV dinners. The freeze-drying technologies that NASA originally developed in Apollo, of course, they're now used in a whole range of convenience foods. When you go to the supermarket today, a lot of those things you buy in a tear-off container, the instant pasta, all those sorts of things, they come from freeze-drying technologies originally developed by NASA. And in fact, a couple of other technologies that also get used widely in the food industry now, irradiation, where the food is treated with radiation in order to kill bacteria, and what they call thermostabilising, where the food is already packaged and then heat treated inside the package to also kill potentially dangerous bacteria. So all of those technologies originally developed for Apollo, and they're now used every day in the processing of your food. Water purification technologies are obviously important on the space station. We're going to need them for a trip to Mars. NASA's been at the forefront of a lot of water purification technology, and this is the kind of if you live in an area, particularly a remote area, where you may not have access to good water on a regular basis or in a disaster period, this is a NASA-based water purification system. It's a bit hard to see these. I couldn't find a better picture, but they're actually shock absorbers in a building in Japan. And they come out of, again, research that was done on shock absorbers for the space shuttle, and they're used, obviously, to protect buildings when they're moving in earth tremors. So they absorb some of the shock and literally stop buildings from shaking themselves apart. So that's an interesting one that's come out of space technology. The fireproof coatings on metal beams in industry, in engineering. That's again a technology derived from some of NASA's space shuttle tile technology. So that protects buildings in the event of a fire. And you may find it interesting to think that when you're driving your high-performance radial tyres, that technology has actually come out of the parachute strings that were developed for the Viking landings on Mars in 1976. So the type of high tensile strength material that was developed for those parachute supports is now incorporated into the material used in these high performance tyres. The microprocessors or the cameras that you find in your, I'll get that right, the pixel sensors that you find in your cameras now, these all come out of NASA imaging technologies, the kind of thing that you find in the space shuttle, in the probes that are on Mars, that NASA was even beginning to experiment with back in the 60s during the moon landings. And the athletic shoes that you're wearing, the sports shoes that you're wearing, the cushioning materials in those actually come out of materials that were developed for the cushioning of the boots on the Apollo spacesuits. So if you're a runner and you like to take pictures, you're again using technologies that came from Apollo. NASA's an enormous developer of software, and every year they make that software available. They have a catalogue that comes out with a whole range of open source softwares that they provide for people to use. Anyone in the world can then just pick them up and run with them to develop those softwares in any way that their imagination and creativity allows them to. Some of you may be familiar with OpenStack cloud software. This is another development that came out of NASA that they made openly available for companies to then use in the cloud computing market. Now, some things that NASA has developed are a little bit unusual. You may not think of them as spin-offs from space, but management technology actually came from, or not management technology overall, but certain types of management systems, management technologies, came out of the way that project management had to be developed for Apollo. So a lot of the lessons that NASA learned at that time were then quantified into management training for later generations, so that, again, the basis of management programs today goes back to a lot of the project management for Apollo. So just quickly summarising some of the things that we've looked at in this single slide. A few things I haven't mentioned, pacemakers, for example, these are another development. What have we got here? The robot-guided wheelchair, the dry-film machinery lubricants. NASA originally developed those for the aviation industry, but they've now been used quite a lot in the mining industry as well as in automotives. Water purification, we've mentioned that. Ultrasound scanners, laser surgery, again, that's come from techniques NASA originally developed for completely unrelated functions, mainly for aircraft inspection and inspection of spacecraft components and things. So quite a range of things that have come out of NASA's research in taking us to space. And to me, another important thing that has come from space, and what it's done for me, and I hope it's done for you, is the amazing scientific knowledge that it's brought us about the planets in our solar system and about the universe beyond. Space telescopes like Hubble, you may not think they have an everyday application to your life, and in a lot of ways they don't. But I hope that they actually do have a spiritual application to your life. Make you feel some of the awe and wonder of the universe when you see the images that come from this research. So going back to our old codger and what space exploration ever done for him, well, here you can see some of the things that it has actually given him to make his life better. Thank you. Any questions?
I think hopefully we'll be able to get this going, so if you just put your hand up, I can do a roving mic.
Oh.
What sort of technologies is the ISS currently testing that could have potential impact or have come as you could criticize perhaps in 50 years time?
that's a hard question to answer, only in the sense that there's quite a lot of research going on. A lot of research, obviously, in life sciences areas, material science, excuse me. Let me see. Just trying to, that's the thing, there's so many things, it's hard almost to zero down on them. In some ways, interesting work being done on food science. So in other words, developing how we might feed astronauts on the way to Mars, for example. And of course, it's often very hard to determine what a spin-off might be from some particular experiment. So, you know, there's nothing that sort of leaps out to me immediately and says, you know, we're doing X on the space station and that will result in Y and Z fantastic things happening on Earth. It's very hard to say that exactly, but by developing and deriving fundamental data on different effects on the space station, somebody else might look at that and say, well, we can use that to do that. And that might be something that changes the world in the future. You know, I didn't actually talk about it here because it's actually another one of those things that people think NASA invented and didn't, and that of course is the microprocessor. You know, NASA often gets credit for supposedly, for starting the computer revolution. That's not quite true. The microprocessor had already been developed in the early 60s, but NASA had a need for that advanced computing power that microprocessors could provide. And because they needed large numbers of the chips, this gave some of these early technology companies in that area the ability to ramp up and start finding ways to produce larger and larger quantities of chips. And of course, NASA was continually trying to find ways to get more and more data onto a single chip so that you've got more and more computing power in space. But they were asking the companies to do that. If you know what I mean. So they were asking the technology companies to do it. So NASA gave them the impetus, just like it did for many other things, but it wasn't the space program itself that actually created many of these things. And that's the thing with this research from the ISS. Somebody, you know, some small company might see a particular result, pick up on it, say, well, that will work with this other research I've seen over here, and who knows what will come out of that. Anybody else? Okay, well, in that case, thank you all very much.